Okay, here we go. So what are we given here? So we're given 250 miles as a distance. We're trying to solve for speed x, that's r, in miles per hour. Enter an equation that can be used to find the speed of the train if the time to travel, so they're giving us what else then? The time is 5 hours. Giving us time, yeah, good. So we got time t. Well, how are distance and rate and time related? Two ways you could do it.
D equals dr.
D equals, yeah, distance equals rate times time. It's probably the most common way you guys did it, right? Distance equals rate times time, right? Which just looks like that.
RT. Oh.
Right, and then all I would do, it doesn't make a difference either way. And then all I'm gonna do is just plug in stuff that I know. So what's the distance?
250.
250. What's the time?
5 hours.
5 hours. And what are we calling the rate?
The R. It's x.
Well, x, right? They define it as x, and so that's, if we plug stuff in, that's what we get. And so 250 equals x times 5. Well, what's x times 5? How would we write that?
5x.
5x, yeah. So there's the equation we would use, right? Okay, no big deal. All right. Something like this, no big deal. And these word problems, I'm telling you, the word problems are the easiest ones. They really are. They look hard because there's lots of writing, but if you just take the time to read them, they're the easiest ones. The formula for the rate at which water is flowing is R equals V over T, where R is the rate, V is the volume in gallons, T is the amount of time in seconds. So it says select an appropriate measurement unit for the rate. Well, what's it going to be? If V is in gallons and T is in seconds, G over S, gallons per second, right? No big deal. Okay? Yeah, so I'm telling you, these are the easiest ones. Okay, stuff like this. Let's go through, let's go through one of these. Now these also are really simple. Once you've done one or two of these, you can do any of them. They're all the same. And you're gonna see, for sure, you're gonna see at least one, if not many, problems like this. So a store sells used and new video games. New video games cost more than used video games, but all the new ones cost the same and all the used ones cost the same, is he right? Omar spends a total of $84 on 4 used video games and 2 new video games. Sally spent a total of $78 on 6 used and 1 new. Okay? So there's all the information about what people did. So let's kind of just section that off. So there's all the information about how much money was spent to get what. Now the question that we're trying to answer is, Janet has $120 to spend. Enter the number of used video games Janet can purchase after she purchases 3 new video games. Well, for us to answer that, wouldn't we probably need to know how much they cost, right? So everything up here above is what we have to use to determine what are the unknowns. You tell me.
How much the video games cost.
Okay, so used and new, right? So those will define our variables then. Like we could say something like, let's let X equal the used cost and Y equals the new cost, right? And so let's take each of these statements then and let's turn them into something we can work with algebraically, an equation, right? So how about this one? Omar spent a total of $84 on 4 used and 2 new. What does that look like as an equation then?
84 equals
4x plus 2y. Everybody see that?
Yep.
Makes sense, right? 4 used times the cost of a used video game. That tells me the total amount of money he's spending on used video games, right? 2 new games at Y dollars per game, right?
Equals 84.
Is going to equal how much he's spending on the new games, and the total he's spending is 84, right? Okay, so what about, let's do the same thing for, how about Sally? right? Sally spent a total of $78 on 6 used and 1 new, right? So what's the equation for Sally's stuff?
6x
plus y equals
78.
Okay? And so all I've got to do is just solve that linear system, right? And that's going to give me the cost of a used game and the cost of a new game, and then I can easily answer whatever they're asking me once I know that stuff, right? Okay, so that's the issue. Now let's go through this 2 ways. Let's go through this once. Let's go through this once, kind of just remembering and reviewing the process that we do algebraically. And then we'll maybe talk about how we can do this on Desmos. Okay, remember, we reviewed this stuff earlier in the, how did we go about doing this? Solving a linear system. Now just kind of think back and see if you can pull up your prior knowledge.
Do you add everything together?
Well, there's it's more than just do you do this or that. It's a process, right? But let's first of all, what are the 2 different strategies we can use? We could substitute, right? We could always substitute. And so in this case, we'd probably solve for y in the bottom one if we substitute, because it's easy to isolate, right? So one strategy would be to isolate y in the bottom equation and then substitute it into the top. That's fine. That works great. What's the other method? What do we call it? Elimination, right? Elimination. And being as this is set up in standard form, ax plus by equals c form, that's what I would do, right? We've had a lot of practice recently doing substitution with harder systems, with nonlinear systems, right? With linear quadratic systems. So we're already getting pretty good at that. We've done a lot of substitution. Let's go back and remember how to do an elimination problem, okay? So what did we say about that? Remember, I showed you kind of a trick for organizing your thinking on this. What's going to be the variable that we're going to try to eliminate probably? The y, aren't we, right? We're going to multiply, because we only have to multiply one equation. Which equation are we going to multiply and by what?
bottom by negative.
Bottom by -2. So we can get a 2y and a -2y that add to 0. So remember what we said then. The equation that's unaffected, we just draw an arrow, right? It stays the same. So then we're going to end up with 4x plus 2y equals 84, and the bottom equation will multiply everything by -2, right? And what's that going to give us when we distribute the -2? Okay. -156, good. Okay, and we'll add all that stuff up, and sure enough, the y's cancel. 4x minus 12x is?
Negative 8.
Good, -8x equals, what's that, -72?
Sure.
Okay, and so what do we do next? Divide by -8, and that's going to give us what? 9. Good. So x equals 9, right? That tells us something important, doesn't it? Now, if I want to find y, where would I go?
Plug it back in.
Plug it back in. Any of them would work, but what's probably the easiest one?
The 4 one.
6x plus y.
I'd say probably that one, because it's got a single y there, right? Trying to solve for y. So let's plug in to the pink equation. That's not pink. What is that? What color is that?
Pink.
No, come on, what is that? It's got to be something fancier than that.
Pink.
Fuchsia, I like that better. That sounds much fancier. Okay, so we get 6 times 9 plus y equals 78. Okay, so 6 times 9 is what?
54.
So what's y? If I subtract 54 from both sides, what do I get? 24. Okay, so we've got our values then. Of course, we could check that too. How? Plug them back in. Yeah, plug them back into our original system and see if they work, right? Okay, so now we know the costs. The costs are, the used cost was $9, the new cost was $24. And so now it should be pretty easy to answer this other question, right? So Janet has $120 to spend. She purchases 3 new video games. So what's going to be the cost of those 3 new video games? So yeah, that's going to be 3 times $24, right? Which is 72. She starts off with 120, right? So how much does she have left to spend on used video games? Well, we can figure it out, right? 120 minus 72 is
48.
48. So she has 48 for used video games. How do we figure out how many she can buy? Yeah, divided by 9. Good. So 48 divided by 9 is going to be what? 5. And how much is left over? $3. 3, good. So 3 nights, right? So she can buy a total of 5 and 3 nights video games. Well, can you buy 3 nights of a video game?
No.
So how many can she afford? 5. Yeah. So the answer is 5. Right? Make sense? Okay, how could we do this on Desmos? Because you can do it really easily on Desmos.
Plug them both in.
Plug them both in, yeah. Real simple, right? All we got to do on Desmos is solve that system, right? There's calculator, let's see. Okay, so all I've got to do on Desmos, all I've got to do on Desmos here is just type in our system, right? So we've got 4x plus 2y equals 84. And if I zoom out, that's going to give me a line. There's my line, right? And then we've got 6x plus y equals 78. There's another line, and what do you know? The coordinates, x and y coordinates, are 9 and 24. So we know what that means, right? We already defined what the variables are. So we already defined what the variables are. The variables are just used and new cost, right? So we get $9 and $24, and then the rest was easy from there, wasn't it? Right? Okay? How about something like that? Nina has some money saved for a vacation she has planned. The vacation will cost a total of $1,600. She will put $150 every week into her account to help pay for the vacation. She will have enough money for the vacation in 8 weeks. Okay, so that sounds like a linear equation, doesn't it? Right? She's putting aside the same amount every week, right? Does that make sense? And so doesn't this match a situation like this where we've got something like y equals mx plus b? Well, what would y be in this case?
1,600.
1,600. So y is going to be the total saved, right? What's probably our independent variable?
0. Oh, no.
So you're right, it's 8 in this case, number of weeks, isn't it?
I
Right?
thought you were talking about B.
So number of weeks, what's m going to be?
150.
Yeah, the amount she's saving per week, right? Saved per,
Does she have $0 in her account right now? Or-
that, we don't know, do we? What would B be in this case?
Whatever 8 times
It's her starting value, so how much she has in her.
minus 1,600.
Okay, 1,600 minus that start value, isn't it? It's how much she already has in her account. Maybe there is, maybe there isn't. We don't know yet, do we? But this is her, what do we call that, initial balance maybe?
What's 8 times 150?
Okay, so we could plug in a bunch of stuff. I guess we need to know, first of all, if there is an initial balance, right? So we know the values. You already told me that the total 1,600, for Nina's situation, she's saving 150 bucks a month and it takes her, a week, and it takes her 8 weeks, right? We don't know what B is, so let's find out. Maybe it is 0, who knows? So we're gonna get 1,600 equals
150.
150
8
times 8 plus
B
B.
times 150 times 8 minus it, and it's like 1,200. So she got 400 bucks.
Ah, okay, there we go. Right, so if we do the math here, which is a good thing to do in math class.
Not always.
Not always?
No.
I think sleep sounds really good right now.
No.
Yeah.
So if we subtract 1,200 from both sides, good, we get B equals 400. That's important. That's her initial balance, isn't it? Okay, so now what about part 2? If Nina was able to save $200 a week instead of $150 a week, how many fewer weeks would it take her to save enough money for the vacation? Okay? So then all we got to do is what? Now what are we solving for this time?
Put 200 bucks.
We're solving for X, aren't we? Yeah, right. We're solving for the number of weeks because we don't know. That's what we're trying to find. But we know all the other stuff, right? So for this situation, what are we going to get for our equation then? We still get 1,600 is what she's trying to solve, or save, right?
Equals 200x.
There you go, 200x plus
400.
400, there you go. Right.
Subtract 400.
What do we find? Subtract 400, 1,200 equals 200x.
That's what I said earlier. Remember?
So 1,200 divided by 200 is what?
6. That's the first number I said is 6.
Okay,
I'm just gonna guess on these.
right, x equals 6. Is that our answer?
Yep.
No.
That's my answer.
Genius.
We just have to plug it back in and figure out the rest of the answer. But
Okay, but what is the rest of the answer then? It says how many fewer weeks? You gotta make sure
2.
you find, exactly, you gotta make sure you find that question mark and see what are they actually asking, right? And that's something you gotta make sure you do on this test. Because they'll try to trick you with stuff like this. So you did the math, and 6 is an important number, but really what they're looking for is 8 minus 6. So the answer is really 2
So the answer is 2.
weeks. Yep.
You're wrong. Cam didn't even make a guess, so therefore he's wrong too.
No. Okay, what about this one now? And we want to. This is an inequality question, right? So we gotta get used to some terminology here. You have to think about this. You would have talked about this back in Algebra 1, and we did a little bit at the start of the year. So a student earns $7.50 per hour at her part-time job. She wants to earn at least $200. Okay, so let's interpret that. When you see something like at least, think what that means. Always kind of ask yourself, okay, so what is that implying? So she wants to earn at least $200, would she be satisfied with $199?
No.
No. Would she be satisfied with $200?
Yes.
Yes. $201?
Yes.
Yes. Okay, so she could earn
She's
more than 200 or more than 200, but not less. What kind of an inequality does that sound like?
Be less than or equal to, more than or equal to.
More than or equal to. Okay, so she wants to earn greater than or equal to, more than or equal to 200. Well, what's the expression going to be that determines how much she's made? If she's earning $7.50 per hour, and we're trying to figure out how many hours H,
750x.
750H, right?
750h.
Right, because we're using H, so we want 750 times H has to be greater than or equal to 200. So that is the answer to part 1. Enter an inequality that represents all of the possible numbers of hours H the student could work to meet her goal, right? I guess we'd probably want to divide by 750 to isolate the H, right? So if we do that,
37.
it's gonna give us H is greater than or equal to whatever that is. That's,
38 and above.
so it's gonna, what is that gonna be?
38 times
26.
5.
Okay, good, so
No, not that.
26.6 repeating, right?
Yep.
Okay, so then part 2. So that's what she has to earn. That's how much she has to work. Enter the least whole number of hours the student needs to work in order to earn at least $200. 27. If she works 26, is she going to have made $200?
No.
It's going to be less, because in order to make exactly 200, she would have to work 26.6 hours, 26.6 repeating hours, right? But if you have to work,
that's a lot of
if you can't work a partial hour, let's say for this job, you have to work whole hour increments, then she's got to round up to the next one, right? If she rounds down to 26, she won't meet her goal. Okay, so part 2, H equals 27 hours. Okay, make sense? Okay, there's guaranteed to be some problems like that where you've got to interpret a decimal result in terms of a real world answer and either round up or round down, depending which one makes sense. Okay? Let's skip that. Okay, what about this one? Let's just set this up, because this is another one where they're just wanting you to enter an equation. No big deal, right? So Mike earns $6.50 per hour plus 4% of his sales. Enter an equation for Mike's total earnings E, right? When he works X hours and has a total of Y sales. Okay, what's that going to look like then? So what am I going to start off with? What equals, what am I going to put on the left side probably? E, yeah, because it's earnings, right? We want to figure out an equation for his earnings, so E equals what? So what about the part up here, the $6.50 per hour? 6.5x, because look, X is the number of hours, isn't it? Right? So there's the $6.50 per hour part. Okay? How about the 4% of his sales, and Y is the amount of sales? Okay, so plus, yeah, how am I going to write that? 4%.
Yeah.
Oh,
0.04, good, because I have to move the decimal 2 places, right, to turn the percent into a decimal. So 0.04 Y. That's it. Right? That's all they want. Okay, questions on that? Okay, what about one like this? Let's just do this on Desmos. You just tell me what to type in here. Let's read through it first. So, the basketball team sold t-shirts and hats as a fundraiser. They sold a total of 23 items and made a profit of $246. They made a profit of $10 for every t-shirt they sold and $12 for every hat they sold. Determine the number of t-shirts and the number of hats the basketball team sold. So what are the unknowns? What are we trying to find?
How much each
T-shirts and hats.
cost?
Not cost.
How much they sold and hats.
How many they sold, right. So we're trying, let's write that down then. So we want, X is going to be the number of t-shirts, right? What's Y?
Number of hats.
Okay, good. So those are the variables, right? So now we got to look at the numbers and see if we can turn each of those numbers into an equation. What about the first statement? They sold a total of 23 items.
That's your X, or not your X. Well, like it is in your Y equals MX plus B.
Okay, how am I going to, if X is the number of t-shirts and Y is the number of hats, how can I come up with an equation that uses X's and Y's there? If the total number of items is 23.
M.
X plus Y equals 23.
X plus Y is 23, right? That's all that is. That comes up a lot. When you're doing these kinds of systems problems, this is really common. There's going to be one equation. Oftentimes, it's just going to be what's the total number of things that you're trying to figure out, right? So it's just going to be the sum of the variables lots of times. So x plus y equals 23. There's our line. Okay, good. What about the next one? Total profit's $246. There's a profit of $10 per shirt and $12 per hat.
So it would be 10x plus 12y equals 246.
There you go. And where's the solution going to be?
119. Yeah, it's somewhere right there.
Point of intersection.
15 hats.
15, be careful.
8 hats.
15 shirts, 8 hats.
15 shirts, 8 hats, right? Because we got to go, we defined X as the number of shirts. Okay? Good, good. Okay, what about this? This is simple stuff. Let's do a quick review, very brief review of some simple statistics stuff. Okay? You would have probably talked about this in Algebra 1. You would have done some statistics stuff at the end of Algebra 1. So this is just generating a line plot. Sometimes we call it a dot plot.
Dot plot.
Okay? You probably called it a dot plot.
Dot
Same
plot.
thing.
Dot plot.
So it says click above the numbers to create a line plot, dot plot, for the given percent chances of rain in different cities. Okay, so these are the percent chances of rain that they're giving us, right? And what do? They don't tell us what the cities are. That's not really relevant here. We're just trying to make a plot. All this is a frequency plot of how often do cities have certain percentages, right? What's the most, if you, among this group of cities, we want to be able to look at this thing and determine how likely is it that the percent chance of rain is going to be this comparatively, right? What do?
You just,
Well, if it asks,
your median's 80, because there's 4.
True, and we'll talk about median and mean in a second. But for this one, all we're going to do is
But
we're
you
just
got
going to,
65.
for each occurrence, I'm just going to make a dot, or in this case, I'm going to fill in a square. If you click on the SBAC test, you click on that, it'll shade in that square.
So 2, 2, 4, 1, 3, 10.
Okay, does that make sense? I'm going to get 2 dots above 65, because that happened twice.
2, 4,
For 70, I'm going to get 2.
3, 1. You got that?
For 80, I'm going to get 1, 2, 3, 4. For 85, I get 1.
Except for it's gonna skip 75.
95, I get 3. Oops. Uh-oh.
Oh, no. You made a mistake. I'm gonna take a picture.
And then 100, there's 1. I don't know where that is, but I don't want to live there.
Seattle.
Probably Seattle, yeah. Okay. That's our answer, right? Okay, so let's take just a quick tour of statistical measures. Okay, so let's think in terms of mean, median, mode, right? So what if I wanted to calculate the mean of all those numbers? What would I do?
Add them together.
Add them together and
Divide by however
divide by however many
many.
there are, right? So mean is just an average, right? What about the median? What would I do?
Just go to middle.
Go in the middle. Okay, so
There's 2.
for these, let's see, we got how many? Let's count the number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? If it's an even number, but because it's 13, I could count in from the edges, right? So there's 1, 2, 3, 4, 5, 6, and that's the middle value, isn't it? Makes sense, doesn't it? Out of 13, the middle value would be the 7th one, because I'd want to have 6 on each side, right? You get that? So that's the middle value, so the median is 80. What's the mode?
Is it like the first?
No.
The mode means most.
Yeah,
Oh,
yeah.
100.
So it's going to be 80, the most frequently occurring
Oh,
one. Not the most, right? The most is just the maximum, the least is the minimum, right? But the most frequently occurring one, the one that happens the most, is the mode. which is 80 in this case, because I get 4 of them, right? So let's look at a couple more samples. What if we did one like this? What if we had 1, 2, 3, 4, 5, 6, 7. Average is easy. Add them all up and divide by 7, right? Because there's 7 numbers. The median is what? 4, because that's the middle value. I've got 3 on the left and 3 on the right. Okay, but what if now I do this?
You add
It'll be
together
between 4 and 5.
Okay, good. Now there is no one middle value, is there? When I scoot into the middle, look what happens. I'm going to have 4 there and 4 there, so the middle value falls between 2 numbers, right? So when that happens, all I have to do is just average those 2 numbers. Add them and divide by 2. What's the average of 4 and 5? 1.5, right? It's going to be 4 plus 5 is 9, divided by 2 is 4.5, right? So that's going to be 4.5 would be the median. Okay, make sense? Okay, another one let's take a quick look at. Let's look at box and whisker plot. They don't give us any examples, but I'll just make one up. You guys remember box and whisker plot?
No.
Okay, let's go through. That's the same thing as the, sometimes we call it the 5-number summary. You ever remember doing 5-number summaries?
Yeah, like
Vaguely?
4th
Okay,
grade.
well, let's look at one. So here's the numbers we're going to use. Let's say our numbers are 1, 2, 2, 4, 5, 6, 6, 6, 6, 7,
Right, I did
7,
4 of those, and now
10, 13,
and then
15. Let's look at that. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, good. So it's 14. Okay? So if we end up with, then when we want to create our 5-number summary, here's really what we're doing. We're gonna want to know what is the, we're gonna build a picture that looks like this. Right? Box and whisker plot. Okay? So the middle value is the median. This is going to be Q1, right? So the end of the first quartile. This is Q3, which is the end of the third quartile. And then this would be Q4
Oh, I know what this is.
and Q0, right? So that's like just the minimum and the maximum values. So these are easy. What goes on the left and the right?
15.
1 and 15.
Then like 3.
Okay. So the median. Now we've got an even number, right? Didn't we say didn't I count 14? 1, 2, 3, 4. So then we're just going to go in. We're going to leave the middle 2. So we'll go in 3, 4, 5, 6. 3, 4, 5, 6. And so what's the average of 6 and 6? 6. Okay, so the median is 6. Okay, then all we do, if that's the median, then we look at the group to the left of the median and the group to the right of the median, and we're going to find the median of that group. So what's the median of these guys? 3. It's going to be 3, isn't it? Because the middle value falls between 2 and 4, and the average of 2 and 4 is 3. So 3 goes there. Here we get the middle value falls between 7 and 10. What's the average of 7 and 10? 8.5, 17 over 2, right? So 8.5 goes there. Okay, and that's our 5-number summary. So that tells us, what that tells us is that 25% of the numbers fall from 1 to 3, 25% fall between 3 and 6, 25% fall between 6 and 8.5, and 25% fall between 8.5 and 15. Okay? And so like if you take a standardized test and it tells you your score is in the 4th quartile, that means that you're in between the top 75% and 100% of the scores. Okay? You have one of the top 1/4 of the scores that they collected.
That's not
Okay.
good.
That make sense?
Yeah.
Okay? So what about this then? Let's look at a problem like this. You're likely to see one like this, and I can make this really, we can make this simple. These are supposed to be really hard, but they're not. You already know the stuff. If you just organize your thinking, you already know how to think about this. So Michael took 12 tests in his math class. His lowest test score was 78. His highest test score was 98. Okay? So what's that tell you about his average?
It's all
In between.
It's in between somewhere, right? In between 78 and 98. On the 13th test, he earned a 64, which is his lowest score. Select whether the value of each statistic for his test scores is increased, decreased, or could not be determined when the last test score was added. So what about his, start with mean? That's just average, right? What's going to happen to your test average if you take a test that is, your last test is your lowest test? What's that guaranteed to do to your average?
bring it down.
It's got to bring it down, doesn't it?
But you don't know what it is because you don't know all the other middle tests.
You're right, you don't know what it is,
They
but
can
you
all
know
be
that it
97.
has to go down, doesn't it?
Yeah.
Right? Is that agreed?
Yep.
Because now when you add up that total and divide by 13, you have to get a lower number than you did before, right? That's what outliers do. If you have an outlier, so if you have a really small or a really big value, they are going to drag the average value up or down, right? And you're familiar with that, just calculating your grades. Okay, what about the median?
That doesn't, I mean, that you can find.
But we don't know what any of the test scores are, right? All we know is that
Oh, never
his
mind.
previous low was a 78 and his previous high was a 98. So can you think of a case where scoring a 64 would change the median? Yeah, it might, right? What if, does that make sense? Because what if his test scores looked like this? Let's just make a little profile here. So he had, what was his lowest again, 74?
78.
78, and his highest was a 94?
Now it's
Okay.
64 though.
All right, not that it really matters. 78, 98, okay? So before, we had 78 and 98, right? And let's say we go through and the middle values looked like this. Let's say the middle values looked like 84, 85, 86 of his 12, right? Actually, let's see, I just want to have maybe, let me put 4 of them in there. I mean, let me put 4.
87.
Right? So say those were the middle values.
85.
So if there were 12 to start with, he would have had 6 on the left and 6 on the right. And so his median would have been an 85.5, right? So in this case, what's going to happen if I add a 64 out there? Now what's the middle value become?
85.
Becomes 85. It changed it, didn't it? Right? It went from 85.5 to 85. Right? It shifted the middle value from being between those two to being right there. Okay? Can you think of a case where it wouldn't change it?
You do another side.
Yeah. Well, hold it. Maybe not. How would it not change it? How would adding that 64 not change what the middle value was, what the number in the middle was?
Because that's
Your teacher dropped that test.
No, that's not. It's not whether the teacher drops it or not. Think about those middle values. What if his 4 middle tests were all 86s,
Oh.
right? So then we're starting off with the middle value being there. What's the average of 86 and 86?
86.
Okay, we add an extra one down here, and that's going to scoot the middle value to be that one. Well, it's the same value, right?
Oh.
The median didn't change because there were multiple identical values in the middle, right? So does it make sense then that for this one, this couldn't be, this one was increased, whoops. This one was increased. This one couldn't be determined. Standard deviation. So the answer to that, I'm just going to tell you. Standard deviation, it just tells you the width of the distribution, right? You guys, you probably didn't even talk about standard deviations. So if you had the number of scores, let's say that this is your score, the scores in the class going from 0 up to 100, And then up here is just the number of students getting those. You've heard about grading on a curve, right? When you grade on a curve, what you find is that if you have a lot of numbers that are collected together in a group, the more numbers you have, the more it starts to look like this normal curve, where this value right there is going to be the average. Okay, that's the average of all the test scores. So if this is the mean, what do you think is going to happen if we throw in an outlier? Do you think the standard deviation is going to be affected? Yeah, because it depends on the mean, right? The middle of the standard deviation is going to be, does that make sense?
What's an outlier?
An outlier means a value, a really big or a really small value. Like 64 was
Way down.
our smallest, right? That was small compared to all the other ones. So what you can remember about this is that standard deviation always gets connected to the mean. They're always going to act similarly, and so the standard deviation is going to be, well, that should have been decreased, shouldn't it? Standard deviation is going to get decreased. Okay? All right, have a good lunch.